Hello students, today we will discuss a very basic concept to find prime factors of a number. You all are familiar how to find prime factor of a number. For example, let I want to find prime factor of 140. So, you know the method, as 140 is divisible by 2, so we'll divide it by 2, and again this 70 is divisible by 2, so 35. Now 5, 7 and 7, 1. So we have prime factor of 140 as 2 into 2 into 5 into 7, or we can express it as 2 to the power 2, 5 and 7. We can represent this method as tree method also. For tree method, here we have 140. Now choose a number that can divide 140, that is 2. When we divide it, we will have 70. Now for 70, I will divide it with 2, and not remainder, the answer is 35. For 35, I will choose another factor, that is 5, and here we have 7. For 7 again, I will divide it by 7, and now I have 1. So 2, 2, 5 and 7 are prime factor. This is tree method to represent this factorization. So again, we will get the same answer. As we can see, the prime factors are 2, 2, 5 and 7. So this is tree method and this is your regular method. For example, 3, 8, 2, 5. If I want to find its prime factor, as it is not divisible by 2, so we'll try with 3. Yes, it is divisible by 3. And directly I will do, if I will divide, 3, 1 is 3, 3, 2, 6, 7 and 5. Yes. 1 to 7, 5. I will try with 3. So 3, 4 is 12, 2 is 6 and 3, 5 is 15. 425. For 425 again I will do. It is not possible with 3. Let's try with 5. Prime numbers. I will choose all the prime numbers here from the beginning. So 5 into 8, 40 and 5. For 85, it is not divisible by 3. So again 5. So here 17. Now 17 itself is divisible by 17. So all the numbers 3, 5, 5 and 17 are its prime factor. 3, 3, 5, 5 and 17 are the prime factors. So this is simply, you have to just change the format of doing that factorization, and these are the prime factors. I can express it as 3 square, 5 square and 17. But why I am discussing with you? Because today we will learn another definition for computation of HCF and LCM. using fundamental theorem of arithmetic. Later I will explain you that fundamental theorem of arithmetic also. But today I just want to explain a new definition of HCF using that theorem, that is fundamental theorem of arithmetic. So I will use this method of factorization or a regular method of factorization first to find the prime factors and then to determine the HCF and LCM. Here is the definition of HCF and LCM. HCF of two numbers A and B, that is product of the smallest power of each common prime factor. Product of smallest power of each common prime factor. And for LCM of A and B, product of greatest power of each prime factor involved. Sorry, there is a mistake. Each prime factor, each prime. Okay, it is correct. Product of the greatest power of each prime factor. Here, just each common prime factor. I will explain you what is the difference between the two. The first difference here, in HCF we will consider the smallest power, and in LCM we will consider the greatest power. Now each common, it means for HCF we will go for only common factors. In LCM we will consider each prime factor. Here we will consider only common factor, and here we will consider all the factors involved in A and B. I will explain you with example. Let we want to find LCM and HCF of two numbers 510 and 92. So first we will find the prime factors, because here according to both the definition we need prime factors of the numbers A and B. So we can consider this as A and we can consider the second number as B. So we'll first find the prime factors. This is 510. So using tree method, this is 510. The first prime number that can divide is 2. And here I am left with 225. For 225 it is not divisible by 2. Try with 3. So yes, it is divisible by 3. So when I divided 3, here I have 85. For 85 I will check it with 3, 3 to 6 not 3, so I will use 5. So 5, 1 is 5 and 5, 7 is 35. 17, it is divisible by just 17. So prime factors of 510, is 2 into 3 into 5 into 17. Similarly, we will calculate prime factor of 92 also using tree method. So the first prime number is 2, that can divide it, and when 92 is divided by 2, here we will left with 46. Now when 46 is divided with 2, here we will have 23, and for 23 the factor is 23. So prime factor of 92 can be written as 2 into 2 into 23, or 2 square into 23. Now as per our definition for HCF of 510 and 92, we will consider the definition again. According to definition, product of the smallest power of each common prime factor. So first we will check the common prime factor. Here the common prime factor is 2 and 2. And from these two common factors, I have to choose the product of smallest power. So we can see the smallest power is here. The common factor are 2 and 2, and the smallest one is here 2, because the power is 1, here the power is 2, so this is the HCF. For LCM of these two same numbers, 510 and 92, each prime factor and the greatest power, each prime factor. So here the factors are 2, 3, 5, 17 and 23. And the greatest power. So here among 2, the greatest power is 2 raised to 2. So this is 2 raised to 2. Here nothing is there with 3. So I can write it as 3 to the power 0. The greatest is this one, 3 to the power 1. Because here it is 3 to the power 0. Nothing is there, so 3 to the power 0. So I can consider this 3. Similarly, nothing is similar to 5. So 5 to the power 0 and 5 to the power 1. So this one is greatest. For 17, again I will consider 17 to the power 0 and here 17 to the power 1. So I will choose the greatest one. And here nothing is in the form of 23. So I can consider 23 to the power 0 and here 23 to the power 1. So 23. So I hope you understand the definition, that how to find the LCM and HCF using fundamental theorem of arithmetic. In HCF you have to find the common, and among the common term you will find the term with least power. In LCM you will consider all the terms but with the greatest power. If you will solve, you will obtain the answer, and that is 2, 3, 4, 6, 0. Now one thing I want to verify you, that the HCF and LCM, the product of LCM and HCF is always equals to the product of the two numbers. See, HCF of A and B, LCM of A and B is equals to product of the two numbers. Now we'll verify. The HCF here is 2. The LCM is 2, 3, 4, 6, 0. The first number was 510 and the second number was 92. If you multiply 2 into 0, 0, 2, 6, 12, 2, 1 carry, 2, 4, 8, 1 carry, and that is 9, 2, 3 is 6, 2 and 2, that is 4. Obviously when you will multiply this 510 with 92, you will obtain the same number, that is 46920. So I can use this format to solve some 1 mark questions that frequently appears in your board paper. Consider an example. Here HCF of two numbers, the two numbers are 306 and 657. The HCF of these two numbers is 9, and the question says find the LCM of the two same numbers, that is 306 and 657. So I can use the property that HCF of two numbers and its product with LCM is equals to the product of the two numbers A and B. So here HCF is 9, LCM we have to calculate A, that is the first number 306, and B, that is the second number 657. For calculation of LCM I can use 306 657 upon 9. Now a simple mathematical calculation. Here we have 34, and now we can multiply the two numbers, and if you multiply, it is equals to 223338. So we can use this to find either LCM or HCF, or out of the 4 terms, if 3 is given, we can calculate the third unknown, one of the unknown term. Based on this concept, I will give you some questions. Try to solve it. Again, if you find any difficulty, you can contact me. Thank you, students.